All right, we're going to turn now to looking at coterminal angles and what that term means. When you talk about two angles that are coterminal with each other, what you're talking about is angles that end in the same position. They have the same terminal arm. So if you had an angle over here and you had it in standard position like that, coterminal angle with that would be one, say, that went backwards to get to that same spot, or one that went forwards but more than one turn to get there and ended in that same spot. So coterminal angles share the same terminal arm. They end in the same spot. All right, so let's look at what that looks like with some specific numbers here. So let's look at the first one I have down here, which is 50 degrees. We'll start with one in degrees. Might be a little easier to work with. So 50 degrees would end up being right around there. Maybe it's a slight bit too much, but it'll work. Let's grab this thing here. If we're going to look at an angle that's coterminal with that, there's a lot of different ones we could choose. Maybe the most obvious, or one of the most obvious, is going backwards around this way to get to that same spot. If this original angle is 50 degrees, then that coterminal angle is going around backwards, it's negative. And since a full turn is 360, it would take me 310 degrees to get back around to that same spot. That angle is coterminal with 50 degrees. Another one you could draw is going all this way here. I'm going to run out of room to write it, but that angle there, it would be our original 50 plus another full turn. So that's going to be 410. So those two angles are coterminal. You could do lots of other ones. You could add one that has two turns, right? You could go 1, 2, and then stop there. Or you could go once and then stop here going backwards. There's an infinite number of angles that are coterminal with that. Now, to get any one of them, you can just do what we did here, which is take that original angle and either add a full turn, or take that original angle and subtract a full turn, or subtract 2 full turns, or add 2 full turns. I got my first one there by saying 50, and really what I did is take away this full turn to get back around to there. If I took away 360, that's what gave me my negative 310 degrees. Or the second one I got is I took 50 degrees and then added a full turn, right, to get to there. If I take my 50 degrees plus 360, that gave me my 410. I could get another one by adding any other multiple of 360, as in 2 times 360, 720. That would give me 770. That's another coterminal. You're going to get it by adding multiples of 360. Now, in fact, if you want to write an expression for all the angles that are coterminal, you can write a general expression for all angles that are coterminal by doing exactly what I just stated there, which is add multiples of that full turn, 360. So you could say I have 50 degrees plus multiples of 360. Multiples here, I'm going to put 360 degrees times n multiples, right? So some number, except for it to be a multiple, that has to be a whole number, or an integer, in fact. So I'm going to put where n is an integer. All right, so your starting point plus multiples of full turns there. All right, let's look at another one in radians this time. All right, 5 pi over 3. Well, this is pi, depending on how familiar at this point you are with radians, and that's 2 pi. Halfway around is pi, and all the way around is 2 pi. So if we're going to figure out what this is, how we're going to think about this is, instead of thinking of this as pi, you're going to think about it as 3 pi over 3, since you're dealing with thirds here. And then you're going to think of this as not 2 pi, but 6 pi over 3, because that's what 2 pi is. And then if you want to figure out where 5 pi over 3 is, well, it's going to be closer to 6 pi over 3, so over there. So we put that there. Now if we're looking for an angle coterminal with that, you could do one that goes backwards here. That would be negative 1 pi over 3. You could go forwards, add on another multiple, so to there, and then another extra term to get there. That's maybe a little harder to think about what that is. That would be, well, we had 5 pi over 3, and then we're going to add on one full turn, which would be 6 pi over 3. That's going to end up being 11 pi over 3. So that's coterminal, that's coterminal. If we want to write an expression for any angle coterminal with that, we can take our starting angle and then add on multiples of a full turn, multiples of 2 pi. So I'm going to write 2 pi times n. That n is going to be an integer, any integer. It's a good practice to say underneath here what it is, where n equals any integer. If I say any integer instead of any whole number, that covers the subtraction. I could do this the same way by saying plus or minus, and then instead of saying integer, saying where it's a whole number. That's up to you. Probably the simplest thing to say that, any integer. Starting angle, multiples of a full turn. That's that general expression. Last one here is a radian angle expressed as a decimal. Now 2.31, again, you don't, I mean, sometimes people write the word radians, but radians are just numbers, they're a ratio, so there's no units at all. So you just say an angle of 2.31, you know you're talking about radians. 2.31 is going to be, if you're trying to figure out what it is, it's going to be about there. Now, the way I know that is because this is pi, but if you think about it in decimal terms, there's 3.14, there's 0. Halfway around here, up here, would be half of pi, which is 1.57 approximately. So 2.31 is somewhere over there. If you're looking for angles coterminal with it, again, you could go backwards here. To figure out what that is, you'd have to do a little subtraction here. You'd have to think, well, one full turn is 2 pi. So I could write 2 pi minus 2.31. Whoops, got an extra digit in there, 2.31. And what's that going to give me? Well, I'm going to just do it approximately here. 6.28 take away 2.31 is going to give me 3.97 approximately. That's probably good enough. If the original angle only had 2 decimals, I'm going to go with that 2 decimals. If we wanted another one that was a positive angle here, we could do our amount to get to there, 2.31, and then add on a multiple of 2 pi, or add on 2 pi. So 2.31 plus 6.28. Now what would that be? That is going to give us 8.59. So that's another one. Now if we want to write for the last thing here, write our general expression. Let's get rid of our green angle there so we can have some room, and a red angle. Our general expression here is going to be, to get any angle here, well, our original starting angle plus multiples of a full turn here. So now, since I'm going to do that, I'm not going to put 6.2 in, I'm going to put 2 pi times n, where n's an integer. Any integer. All right, because I just do multiples of that 2 pi. All right, so that's coterminal angles and how you can find individual ones, and how you can write a general expression for the set of all coterminal angles with a given angle. All right.